In today's video, guys, we're going to be going over systems of equations, and I'm going to give you guys 4 very helpful tips on how to solve using the elimination process. So, very first thing we want to focus on, guys, is lining up our x and our y in that constant, right? Makes it a lot easier for us to eliminate. So, when we're looking at this first problem that we have here, how are we going to eliminate our variable? So let's say we wanted to eliminate our x. So what we need to do is somehow cancel that x out. So what I'm going to do this process, we're going to make the second equation negative. And what I mean by that is I'm going to multiply the second equation, every term in it, by -1. And the reason we're going to do that, guys, is so we could eliminate our x. So once we do that now, our new equation will be -2x plus y is equal to -3. All the terms in the equation, the signs are going to change. So our next step now, when we start combining our variables, we eliminate x because 2, and then remember we're adding 2 plus -2, that's just 0. So we cancel out our x, and then we could move to that move to that third step, which means solve for the other variable. So if we pay attention, we still have y. So after I combine my y, guys, we're gonna have 5y is equal to 10. And this is when the problem turns into a regular equation and we could just solve. So we'll divide by 5. And once we do that, we'll get an answer of y is equal to 2. But let's hold on real quick. Are we actually done with this problem? No, we're not done. So we have to go back and figure out what the other variable is, right? What number is x? What is x equal to? We only know y. So how are we going to do this? We're going to take our answer, y is equal to 2, and we're going to plug it back in and solve for x. So at this step, just remember, you could pick the first equation or the second one, does not matter. So I'm going to pick the second one, right? Well, let's do the first one. We have 2 times x plus 4y is equal to 13. And now we're going to substitute 2 in for y and just solve for our x. All right, so we substituted 2x plus 8 is equal to 13. And just remember, guys, we're solving a regular equation at this step. So I subtract my 8 to combine it with 13, and we have 2x is now equal to, and let's see, what is it equal to now? 13 minus 8. I think that is 5, right? That's 5. So very last step now for us to do is divide by 2. So I divide by 2, and now we can say that we've solved this system of equation, and we have our x, which is 5/2, and we have our y, which is just 2. But when it comes to systems of equations and we're using the elimination process, what if we have a problem where both the variables cancel out? What do we do in a issue in a problem like that? So in the second problem that we're going to take a look at, we have 3x minus 4y is equal to -10. That's equation number 1. Now let's go back and get our second equation. Our second equation is, 3x minus 4y is equal to -13. So when I'm looking at this equation here, both the x's and y's, none of them cancel out. So we're gonna have to make a few changes to the equation like the first one. So what I'm gonna do is let's go and let's multiply the first equation this time. Let's change the first one. So if I want to cancel out x or y, I'm going to want to change its sign. So let's multiply by -1. If we multiply by -1, then we could get a -3x or a 4y, right? We'll have opposite signs. And let me show you guys exactly what I mean by that. So now the first equation turns into negative 3x plus 4y is equal to positive 10. Second equation is absolutely going to stay the same. So I rewrite my second equation. And now I'm going to combine and cancel out my variables. So there's something very weird going on here, right? So negative 3x plus 3x, that's 0. That cancels out, it's gone. Then we go over to positive 4y plus negative 4y. That's also gone. So what we notice is we have 0 is equal to, because nothing's on that left-hand side, right? X and y are 0. They canceled each other out, right? So now we have 0 is equal to 10 plus negative 13. And when we combine those two, we'll get negative 3. But let's think about this real quick, right? Has there ever been a case where 0 is equal to negative 3? Absolutely not. So when we have an answer or a problem like this, guys, where both the variables cancel out, this is a no solution type of system of equations, right? So what this means is that these two equations, the lines, they will never cross each other. They're going to be two parallel lines. There's no x and y that we could solve for, okay? All right. So we talked about having one solution, no solution. Let's go over to infinite solutions where our equations are going to be equal to each other after we eliminate a variable. So let's scroll on down a little bit and let's change the color. So in this third example, this is equation 1. So we have equation number 1. We're going to go back and write equation number 2. And this one is a little bit more challenging because we're probably going to have to multiply by more than negative 1, right? If we want to get the same, let's see, if we want to get the same x, we're going to have to multiply the first equation by 5, and then I'm going to multiply the second equation by 10. And the reason why we're going to do this, guys, is so we could cancel out our x's, okay? And I'm going to show you exactly how to do that right now. So once we multiply equation number 1 by 5, we are going to get 10x minus 30y is equal to 60. All right? And then now we're going to go back and we're going to do the same thing to equation number 2. So just remember, if we want to get rid of our x, what could we multiply negative 5x so that it could have the same number in front of the variable as the first equation, which is 10x? And the answer is just 2. We're going to multiply that equation by 2. So once we do, we're going to have negative 10x plus, wow, 30y is equal to negative 60. All right, let's put our addition sign out here to the left. So when we're looking at this problem, this is a little bit, it's similar to the previous problem, right? So our x is going to be canceled out, and our y is going to cancel out, and then even the constant is going to cancel out. So what we're basically saying right now is that 0 is equal to 0. And that is a true statement, right? Yes, it is. So when we have an issue, not an issue, I'm sorry, when we have a problem like this and we get this as an answer, guys, what they're saying is that this is a infinite solutions type of problem. So what they're saying is this is probably going to be the same exact line. It's probably going to be the same line. They're going to share many, many, many points. Any point on that line is going to be a solution, okay? So when we talk about systems of equations and we're using the elimination method, that means we're getting rid of one of the variables to solve for the other. And before we go, we're just going to do one more problem. One last problem. All right, let's switch over to red and scroll down some more. So our last problem, we have 2x plus y is equal to negative 12. And our second equation is 9x plus y is equal to negative 26. So when I'm looking at this problem real quick, did you guys notice that y has these y's are there's no number in front of y. So if I want to cancel out y, I just need to make one of them negative so we can eliminate it and then solve for the x. So what I'm going to do now is multiply the second equation by negative 1. All right? We'll keep the first equation the same. And then now once we multiply equation number 2 by negative 1, this will be our new equation. Negative 9x minus y is equal to positive 26. All right? Put our addition sign out there. So first off, y's are going to cancel, right? Y, positive y minus y, that's at 0, it's gone. So now we go over to our x. We're going to get negative 7x is equal to positive 14. We subtracted 12 from 26. And what I need to do now, or we need to do now, is divide by negative 7 so that we can figure out the answer to our x. And once we do this, we'll get x is equal to negative 2. Right? So after we get this answer now, don't forget, guys, we have to make sure we take our answer, plug it back in to the other equation to solve for our variable. So we'll scroll down a little bit more and let's just make some more space for this second part of the problem. And a very important tip, you could plug it into equation number 1 or 2. It doesn't matter which equation you use to solve for the other variable. So now we have 2 times x plus negative 2, right? Because, oh, I'm sorry. All right, so hold on, guys. I made a quick mistake. I solved for x. Now we're trying to solve for y. So a little mistake. So let's go back. We have 2 times negative 2 plus y is equal to negative 12. So how are we going to finish this off? We just need to simplify. So negative 4 plus y is equal to negative 12. Once we add 4 on both sides to get y by itself, our final answer would be y is equal to negative 12 plus 4, which will give us negative 8. So our answer, or the ordered pair, would be negative 2, comma, negative 8. So thank you guys for joining us today. This is Algebra 1 with Mr. Peters, systems of equations using the elimination process.